Okay, thank you very much. I'm Pfaff from NASA Goddard. I'm going to give you first a few slides about the ASTRE mission, which is the Atmosphere Space Transition Region Explorer. Our team is composed of Goddard, the Aerospace Corporation, UT Dallas, University of Colorado, UCLA, a company called ASTRE, which is just by serendipity, and Orbital Sciences Corporation, or build our spacecraft. There we go. Essentially what we're looking at is this fundamental science, universal physics of how do neutral gases and ionized gases interact. And these are processes inherent to all the upper atmospheres of all the planets. And essentially this transition region is shown here. It's between basically 100 kilometers and 250 kilometers at the base of the ionosphere, where this interaction is the strongest. And this is the region where the solar EUV is absorbed. At high latitudes, which will be our focus, it's where the magnetospheric energy is. A lot of it is transferred, dissipated. It also sets the region in motion. The neutrals are set in motion by large electric fields from the magnetosphere. It's where the aurora light comes from, and the currents associated with the aurora come down, and then they have to, of course, return. So its current closure happens in this very important region. So ASTRE will provide the missing link in our knowledge of the transfer, the dissipation, and the regulation of the energy and momentum from the sun through the magnetosphere to the upper atmosphere at high latitude. Okay, our mission implementation slide. We'll be gathering accurate measurements of the plasma and neutral gases, the electric and magnetic fields, and the energetic particles, using well-proven instruments, all with excellent flight heritage. We have a 3-axis stabilized spacecraft, uses onboard propulsion to carry out systematic, low-perigee excursions at high latitudes into this transition region. We've managed at Goddard. We've selected Orbital, a Sciences Corporation, who will design, build, and test a highly reliable spacecraft using high-heritage subsystems and proven, well-tested engineering design. My final slide, some points on our relevance. We highly relevant to NASA's heliophysics science objectives and those of highlighted in decadal surveys. Fundamental measurements missing from the heliophysics system observatory, so we leverage simultaneous measurements with SDO, MMS, RBSP. We gather space environment measurements essential for understanding space weather, such as those associated with atmospheric drag, communication and radar outages, GPS positioning, power grid disruptions. And all of this ties into NASA's Living with a Star program, and we gather a lot of the data that were to be gathered with the IT Storm probes, a mission which is currently on hold. It's synergistic with NSF-funded science programs that address the upper atmosphere and magnetosphere, and we will maintain an open, highly accessible database to promote involvement from the entire space science community. So thank you.